I made some progress with my microbit calculator project. I bought a packet of these membrane keypads, which are really inexpensive. I bought a packet of 5 for not very much money, to try and make a calculator using a microbit. I have got a different layout on here, so it's not, the numbers are not laid out in the same way as you get on a calculator keypad, but I've kept the numbers as they are, so I'm going to use the numbers. I'm going to use these letters as some of the operator keys, so they're going to take the place of plus, minus, divide, and so on. And I'm going to use the star key on here is going to be my decimal point, and the hash is going to be my equals key. It's wired up to the microbit using a breakout board. You don't even need a breadboard if you've got the right kind of jumper wires, but I've used a breadboard just to keep it in one place. I'll show you how it works, and then we'll have a look at the code, and you can see exactly how it's wired up. We've got the first 3 pins of the rows, and the first 4 pins of the rows, and the next 4 pins after that are the columns on the display, and I'll show you how that's connected and wired up in a moment. Let's try it out. So let's press 6, and A is multiply times 7, and then if I press equals, we should see the answer to 6 times 7. There we go, 6 times 7 is 42, and if I clear the display, I press A to clear. Let's try another calculation. Let's do 22 divided by 7, and press equals. Let's see what we get. Equals 3.14. Okay, not the world's most accurate calculator, but quite a nice project to increase the functionality of a microbit, which has only got 2 buttons built in on the front there. So suddenly now we've got 16 keys wired up in a relatively simple way. There's no resistors involved at all. All you need is one of these inexpensive membrane keypads, a breakout board for your microbit, and some jumper wires. Let's have a look at how the code works for the calculator. At the beginning of the program, I call a function that just clears all the variables and resets everything back to the beginning. I've got a note on here that tells you how to wire up your keypad matrix, and a little reminder of what each lettered key, if you've got a keypad like mine with A, B, C, D on it, tells you what operators they all represent. And the main part of the program runs in this forever loop. And to speed things up, I have put a while true loop inside the forever loop. When you use a forever loop in MakeCode, it does introduce deliberately a small delay into your program, and you can remove that delay by using a while true loop, so it will keep scanning more quickly. I've made a function called scan keys, and this is quite a long function if you can find it. And what this does is it writes a digital signal out on each row, and then it scans each row in turn by reading the pins that are connected to the columns. And if it gets a digital signal back, it means you've made the switch. And then I've used another function here where I'm building up a string with the number in. Whatever numbers are pressed get added to a string, which we then evaluate when you press an operator or when you press equals. So there's the first row. It's scanning the bottom of my keypad for decimal point, 0, and equals. It's a bit special, the equals one, because here not only are we evaluating the number that we've just entered, but we're going to do some calculation as well. So let's have a look at my functions over here that do that. So let's build string, if I can find them. I have too many functions over here. Right, so have a look at the clear function there that initializes all the variables. The evaluate number does a check to see whether we've got 2 numbers set. We can only calculate 2 numbers with this program. It's very simple. It's only got A and B. You can only multiply or add 2 numbers together, or divide or subtract them. So if A doesn't exist, then it must mean that you're trying to assign a value to A. Otherwise, if B doesn't exist, then you must be trying to assign a value to B to work that out. So that's what the evaluate number function does. The calculate function, if I can find it, it's disappeared off the screen somewhere. Can't actually find it. This is good. Here's the calculate function. If either A or B hasn't been assigned, then at the moment I'm just showing an error. Probably need to do some work on that. And what it does then, if you have assigned values to A and B, it works out what the operator is and does the appropriate function. And because I'm storing all my numbers as strings that I'm compiling, I'm adding to the string every time I add a digit. It has to convert the number held in a string to a numerical value, so it can actually do some mathematical operations on it. And that's why we use this parse to number block. So it's adding, in this case, subtracting, multiplying, or dividing, but taking our numbers that are held in the variables A and B as strings and converting them to numbers before they can get evaluated. So that's pretty much how it works. If we go back to the forever loop here, you can see we've got another couple of functions. If button A is pressed, that's our clear button. So we say clear on the screen, and we call the clear function that clears all our variables. And if button B is pressed, it shows you the whole calculation that you're going to perform on the screen. It doesn't actually calculate it, just shows you what the calculation that you've assigned is. That's more of a debugging feature than anything. So there we go. If you've got any ideas for improving this project, I'd love to hear about it. I think it's quite a neat way of adding some functionality to a microbit. Perhaps you've got some other uses for using a numerical keypad like that. Perhaps you could do some sort of clever combination lock, or maybe you can think of other cases. I think maybe a noughts and crosses game or something like that, or other game uses, maybe a number guessing game. All sorts of possibilities just by adding a really, really inexpensive membrane keypad to a microbit.